Thank you so much. I'm really excited to be here, excited to get to meet everybody today and to also learn about all of the cool stuff that's coming out of Replit, Google Cloud, etc. So if folks can just kind of stream in, there will be things that you want to see on the screen, and everyone should have access to everything that I show today. So you'll want to make sure to get your laptops out, or at least kind of your phones out, to take some screenshots. So as mentioned, my name is Paige. I lead our developer relations team at Google DeepMind. It's newly formed, and we certainly have a lot to talk about. As mentioned a little bit earlier, generative AI is transforming everything that we do at Google. And we have a long and very storied history of building everything from models to open source machine learning frameworks, and also some of the bits and pieces and components that can stitch together and kind of build these overall systems and experiences for AI, including our latest model, which is Gemini. And we've just released Gemini 2.0 Flash. It's free to use, free to try out. We're incorporating it into all of our mini products. It's notable for a couple of reasons. One is that it's multimodal in terms of inputs. So this is nothing new, right? It can understand video, it can understand images, audio, text, code, full code bases, all of the above all at once. But even more importantly, it can also output multimodal content. So in addition to being able to output text and code, it can also create images. It can edit images, and it can generate audio. So when you speak with Gemini, it sounds like you're conversing with a friend. So this is an example of something that you can try out today with Gemini, and we'll see a little bit of this later, just as kind of a hands-on experience. You can upload an image and then ask for it to be reimagined, but there are pixel-perfect kind of changes within the image itself. So here I'm giving it a picture of a car, and I'm asking to turn that car into a convertible. And Gemini, just that one model, is capable of understanding how to accomplish those tasks. We've also been embedding Gemini on robots. So earlier this week, we announced our Gemini kind of visual language action components for some of the robotics that we've been sharing at Google DeepMind. And what this does is you can ask the robot questions in natural language just using your voice. And then behind the scenes, Gemini generates the code and takes the action required in order to navigate the robot. You can try it out today in some of our Google offices. Unfortunately, I did not have enough space in my backpack to bring a robot today. But you can ask it questions to the effect of, please go and get me an apple, please clean up the spill, please kind of sweep the floor, and it's capable of learning how to do those things. Our models come in a broad variety of sizes. So Pro, which is our largest model, it's also our most generally capable. Flash, which is the one we see most commonly used in production. Flash Lite, which is a smaller version of Flash that's super speedy, very lightweight, very cost-effective. And then also Gemini Nano, which is small enough to fit on a Pixel device, as well as within the Chrome browser, and just to be embedded within the Chrome browser. And if you download our latest Chrome Canary release, Gemini Nano is just kind of available locally, where you can use it for inference, to ask questions, to generate code, and you're kind of off to the races. So as I mentioned, we have several models available, including Gemini 2.0 Flash Thinking. They're all available at aistudio.google.com. You can access it with just your Gmail account. And I encourage you to test this out both today and then when you get back home. These models have been doing pretty well on the leaderboard. So this is a screenshot from a couple of weeks ago from the LMSys leaderboard. And we've been investing pretty heavily in things like long context. Long context is pretty important, though I don't think we do a great job of explaining why. We've been able to get up to 10 million tokens in the context window in some of our research experiments, as compared to some of our competitors. And what this means is that you don't have to invest so significantly in things like fine-tuning models or standing up a vector database as you're prototyping. You can just give Gemini all of the information right at inference time and ask for it to make sense of it. So you can say like, hey, here's a video. Here are some emails, whatever you would like. And 1 million tokens ends up being a lot of information. So it's all of the emails that you've sent in the last year, all of the text messages that you could possibly send in a lifetime, hours and hours of podcasts. If you remove all of the commercials, it's the entire first season of Silicon Valley, the TV show, all sorts of stuff that you can give the model. And I am a little bit allergic to slides, so I do not like them. I think it's much more interesting to show things in action. So with that, I'm going to zoom over to AI Studio, and we'll be able to test out some of these things that I've been talking about. So within AI Studio, this is kind of the best place to get access to the latest Gemini models as soon as they come out. If you click here off to the right, you can see a bunch of the different model names, including Flash, Flashlight, Pro Experimental, and Flash Thinking Experimental. You can sort of also use our multimodal live features, which we'll take a look at in a second. You can generate API keys. So if you don't want to go through all of the hassle of kind of accessing a cloud console just to create an API key, you can create one here and attach it to a cloud project. You can also experiment with all of the features that we have available within our model APIs. So things like structured outputs, code execution, which gives Gemini the ability to write, run, and recursively fix code, function calling, grounding with Google search, which we'll also take a look at in a second, and also some safety settings. And you can edit safety settings to your heart's content. I usually turn them all off, just because I think that that lends a little bit easier experimenting. Everything that you do within the context of this UI, if you click Get Code, the code that is needed in order to replicate your experiment is shown to you. Cool. So with that, let's explore how you would use Gemini to accomplish one of these multimodal tasks that we've all been talking about today. I'm going to select a video. This is a video of the American Museum of Natural History. I really love dinosaurs, so I'm going to ask something to the effect of, please create a table with timestamps for all of the dinosaurs that you see in this video. Make sure to include a fun fact about each dinosaur. I'm going to select our flashlight model, which again is kind of the smallest model available. It's 0.075 cents per million tokens, and then I'm going to hit run. And you can see here, kind of off to the right, the token count is updated, so it's around 89,000 tokens for this video. You can see that it's kind of running here off to the side. If I click Get Code and select a language, so right now I've got Python, but I could also select JavaScript or something similar. You can see all of the different file handling components incorporated for me, and you can also see, it looks like Gemini has already created the table with the timestamps and the dinosaur name for this video, which is pretty rad. I also want to call out that, again, 0.075 cents per million tokens. This is around 89,000 tokens. That means that with these models, like Flashlight, 8B, et cetera, you can record everything that you do on your laptop, 365 days a year, 24 hours a day, and analyze it each week with kind of this structured format or with kind of flagging things for less than the price of a cup of fancy coffee each week. So I think we're getting really into this world where AI is going to become just embedded into everything that we do at very low or no cost, right? And from a Google perspective, this is very important because we have billions of users all over the world. They're using everything from docs to sheets to Gmail to YouTube to search. And we need to be able to get the best possible models to them as quickly as possible without breaking the bank. And in order to do that, we have to get creative with the model sizes and the capabilities so that we use onboard compute as much as possible and also cost-effective models as well. So that's an example of video understanding. We've also baked a few different kinds of agents into our Gemini models. And what do I mean by this? So if you ask a model today something to the effect of, please tell me about Gemma 3, Google's latest open model, and hit run, I'm going to go over to Gemini 2 Flash. What the model does is, given that it has a training data cutoff of around 2023, it does not know that the model has been released. It doesn't have any up-to-date information about it. If you go over here and you click grounding with Google search and you rerun it again, you can see that you get a much better example of Gemma 3 is Google's family of latest open weight models. It comes in 4 sizes, 1 billion, 4 billion, 12 billion, et cetera. It's quite efficient, including, you can run the 27 billion parameter version on a single H100, and it has comparable performance to some of the other kind of models that you might have seen from DeepSeek, and it also cites sources. And in order to incorporate this grounding on the most up-to-date information with cited sources, the only thing that you have to do is add as a tool call just this one line right here, tools, Google search, within your model call itself. So it's pretty powerful to be able to do this. I also want to call out something that we have called code execution. And what code execution gives you the ability to do is, if I turn it on right here, I can ask a question, something to the effect of, please create a cluster plot for the iris dataset in scikit-learn. Hopefully everybody is familiar with scikit-learn in the audience. If you're not, I promise it's a real thing. And the iris dataset is very important. But I'm asking Gemini to create a cluster plot for the iris dataset. Make sure to include basic statistics about the dataset, and make sure the plot is using matplotlib or something similar. I hit run. Gemini builds a plan. It's kind of focused on solving the question that I had asked. This one is using the Gemini 2.0 Pro model. And so far, we have around 314,000 tokens. It implements it in terms of executable code. So you can see here that it's using all of the usual suspects. It has some code execution that focuses on the extension. You can see that the code execution fails. So it puts it back inside, reruns it, and then generates a final plot for me using the data set. So what does this mean? I have just given Gemini the ability to write code, to run it. If it encounters errors, it takes the error in the original code, puts it back into itself, and it fixes it until it gets the right result, and it can give me the right output. And again, this kind of code execution agent baked into the API is as simple, when we click this Get Code button, of lots of outputs. It's as simple as just a one-liner saying tool, code execution, etc. So you can bake this into your experiments, into your calls to the API, and it's very straightforward. You don't have to set up your own infrastructure to do it. Cool. Gemini also understands audio. So in addition to being able to do all of these great things with videos, with long-form videos, with PDFs, with basically any kinds of data that you can throw at it, you can also ask it to transcribe audio. And so if I was to sort of click the record audio button, trying to think of something interesting to read out, I'll read out this. DeepLearning.AI, AI Dev 25, the AI Developer Conference, a day of coding, learning, and connecting. And then a whole bunch of these little tiles in the back that feel very similar to if anybody ever played SimCity 2000. It's like, I almost expect to see an arcology building down at the bottom. I'm going to stop recording. I'll add it to the prompt. I'll just pull up our Flash model, and I'll say, please transcribe with timestamps everything that you hear in this audio clip. And then hit run. Yeah. AI Developer Conference, a day of coding, learning, and connecting, and then a whole bunch of these little tiles in the back, very similar noise. So, excellent. And if I try again using our flashlight model, there you go. And so the flashlight model was able to sort of extract out the noise. Very cool. Excellent. So I mentioned that you're able to kind of create some of these examples. You can test them out directly in AI Studio, which again is free to use. It's something that you might want to tackle first before you go to an IDE. That we have integrated Gemini into Cursor, into GitHub Copilot, into continue.dev. There's an extension called RuCode that also allows you to use the Gemini models. So you can use it as your leisure, but you can think of AI Studio as kind of like a vibe check for whatever experiment that you're trying to do before you export the code out to your favorite IDE. Fun. So let me go back to the slide deck. I'm going to try it again. We'll see how far we can get through the presentation, and I might have time for another couple more demos. But as I mentioned, lots of stuff that you can kind of throw at Gemini and ask it to help you make sense out of it. We've also been investing pretty heavily in something called Project Mariner. So just kind of show of hands in the audience, how many folks have heard of Project Mariner? Few hands? Cool. How many people before today had heard of AI Studio? Cool, cool. So several hands. Excellent. So Project Mariner is our kind of agents framework that allows you to kind of run experiments within the context of Google Chrome. So we've baked Gemini into Google Chrome. You can ask it questions in natural language. Like in this instance, I'm asking it to help me find a puppy because cute animals are always a win for any presentation. It starts by searching through Google for a puppy. It finds one, so it picks a website that looks like it might be able to solve my need for a pet. It browses all of the puppies because I didn't specify an interest, though it does know based on kind of like my previous search history what I might be most interested in terms of a puppy. It found Jerry, who is adorable. And then goes through and asks me if I would be interested in kind of going through the process to get the puppy. But this embedded experience can use tools, it can browse, it can navigate through the website, and it's also asking me within each period to give user feedback about what it is doing. Another model that we have available that I'm not sure if folks had a chance to play with is called Flash Thinking Experimental. You can ask it also to do highly complex tasks. So please create a Frogger clone using HTML, JavaScript, and CSS, and then hit run. And you can see that there's a little box here in the center of the screen. If you expand it out, you get to see all of the kind of background thinking that Gemini is doing in order to accomplish this task. So you can see here, it's figuring out what I'm asking. It's sort of deciding on the core game mechanics. It's doing the technology choice breakdown, all of the logic itself. And so you can get the model kind of thoughts behind the scenes before getting the final outputs in HTML, JavaScript, and CSS. Again, available today for you to use to try and to test out for your projects. Cool. And zoom ahead. We've also announced, though we have not yet released, something called our Google DeepMind co-scientist. And this is a tool that we're using today internally in order to accelerate the work that our scientists do within the context of Google DeepMind and also externally. You can think of it as kind of a fleet of Gemini agents that are capable of executing upon research tasks after you give them. So what happens is that a researcher kind of goes to this agent with a hypothesis. The agent helps ideate across potential experiments that could be run. Once the researcher kind of says, yes, go ahead, it frames out the experiments. It can generate the code and do the data analysis in order to kind of execute on each one of them. It captures all of the results, iterating if necessary, and then brings all of the results back to the scientist so they can do their work. We've released this as a blog post just kind of describing the system, but we've already found that it shaves off up to like a decade of work in order to be able to really, really rapidly move through some of these more complex tasks, especially in the biosciences, the physical sciences, and the chemical sciences. Cool. We also have Imagen for image generation, though just recently, this Wednesday, we kind of gave Gemini the ability to generate images itself. So if I go to create prompt, I go to our latest Flash experimental model, and I select images and text. I'm also going to select a file. So let me go ahead and pick one right now. I am going to select Colossal's woolly mouse. So hopefully people can see it on the screen, this cute little guy right here. And I feel really sorry for this mouse in the sense that he looks so AI generated. And it's, like it must be a very sad thing to go through life with everyone thinking that you look a little bit like something that was generated by a large language model. But what I'm going to ask is, please dye this mouse's fur pink and ask Gemini to help with this. And so what happens is you take the input image, you give it to Gemini, and it has the ability to kind of segment out and make edits to the image in order to accomplish the task. So if you wanted to, you could also say something to the effect of, like, please remove the background of the image and have the mouse on a sunny beach in Cancun. And I haven't tested this, so I don't know if well, there you go. So like the pink furred mouse is going on a vacation, which is quite cool. People have also been using this to create 8-bit pixelated art, to build kind of storyboards for many of the comic books or the films that they're curious about. And then you could also use another one of our models, which is called VO, in order to animate out that image. So VO, you can either describe in natural language the video you would like to create, or you can start with kind of a cedar image. And once that's done, you can generate hyper-realistic 8-second clips for incorporating into your projects. Excellent. So one other thing that I want to call out, in case anybody in the audience is working on a startup, thinking about a startup, we have a very generous cloud startup program up to, I believe, $350,000 over the span of 2 years for institutionally funded kind of Series A startups that allows you to get up to $200,000 or $350,000 worth of cloud credits for AI startups. And also lots of opportunities for things like co-marketing or kind of early access to some of our Gemini APIs. Excellent. And so final slide, I want to say thank you. If you remember one thing, please remember to go to aistudio.google.com. I've also added a link to a Gemini hackathon guide if anybody is thinking about using it for some of your upcoming hackathons or your upcoming work. And again, like try out the models natively embedded within things like IDEs, within Cursor, within Copilot, within RuCode, within Klein, whatever your favorite tool of choice is. And feel free to send feedback at any point. I didn't put it on the slide, but my email address is webpage, but Paige spelled like my name, @google.com. Always happy to point folks in the right directions. And I believe we also have at least a few minutes for questions if folks have questions. Yep.
Can you go over the Gemma's context window language? Right? Can you go over a little bit how large and wide you can go?
So yep, there we go. Not yet.
Gemma's context window enlargement is
There we go.
is really impressive and I think really functional. Can you talk a little bit about how you would start to tackle larger code bases? Because the constraints we have currently, we have to work on file-based or function-based activities, and I'd love to be able to work on something larger.
Absolutely. So the question for folks who might not have been able to hear it was, Gemini's context window is pretty significant. How would you go about incorporating large code bases into something like Gemini? And as you can see kind of here within AI Studio, you can connect to full folders, full repos just within Drive. You can also use something like repo to text, which is a way to convert a directory of files into just a single text file. Or you could just give it kind of the full repo. So you could say something like clone the GitHub repo, pull in that directory, and then just add it to add it as files to Gemini. Yep.
So you have a feature called grounded in Google search.
Yes.
The feature for grounded in enterprise data.
Yes. So there is a feature within Vertex AI that allows you to kind of ground. It's kind of like RAG for free. Your own enterprise data. So if you want to ground on Google Search, but also internal sources, if you just want to ground on internal sources, then basically all you have to do is say like, yes, point to the locations in GCS, wherever that information might be. And Gemini's outputs are kind of tailor-made for your company or your enterprise. Yeah.
So far, Gemini has the reasoning capability like ChatGPT-1. And the second question is, instead of trying the images, and the first question is that does the model at Google have the reasoning capability?
Yeah.
The second question is, instead of trying out the AI Studio, can I use the API to upload the image and get a edited image as the result?
Yes. So the first question, we saw a little bit beforehand of kind of the step-by-step thinking that the Gemini thinking model has. I believe the Frogger clone setup where you can see kind of the thinking and the reasoning capabilities of the model before you see the model's outputs. So this Gemini does have reasoning tools use kind of logic baked into model training. For image editing, I don't believe we've released that in GA through the API just yet. But you should be able to use it with the experimental version. And then for the API key, everything that I showed how to do today, you can do with the API key as well. All you have to do is go to AI Studio to generate the API key. And the code that you would need in order to do it is just this copy and pastable code chunk here that you can incorporate into your projects. Cool. Yeah.
Hey, thanks for the time. What about external tooling, specifically MCP?
So if I'm understanding your question correctly, you're asking about MCP server support? Yep. So since MCP is an open standard, we are kind of building examples of using the Gemini APIs with things like MCP. We also have support across LangChain, LangGraph, great open source tools similar to Crew AI or Composio.dev. You can use Gemini models with all of them as well. Yes.
So, I mean, I use it for some development tasks, it generates tons of code. But it takes a significant amount of time to review the code, whether it has done it properly or not. Do you provide any tools for verifying, it has done what I asked it to efficiently check what has been generated?
So actually, you can ask Gemini to review pull requests for you. We've also baked it into our Google Code Assist platform, and you can implement it as a GitHub action. So this is an example of Gemini just kind of automatically responding to a repo whenever somebody makes a pull request to say like, all right, here's a summary of changes, here are the highlights, here's the change log, and then here are kind of the code review comments around this adds a collab notebook, it has merge readiness, and it gives kind of some examples, or a human gives examples for changes that should be made. So it can help with code review as well, not just with the code generation. Yeah, and I think that's all the time we have. Excellent. Thank you so much for your time and attention.
All right.